All right, good afternoon, actually. Everyone, welcome to another day of Advent of Code. We're a bit later than normal, but I blame Zelda for that. And more precisely, what is it, 12 hours of Ocarina of Time randomizers? That was great. Anyway, before we hop into today, I actually spent some time tinkering with my day 19 solution yesterday, because I didn't finish part 2 yet in the morning, because of course we had the Zelda thing. So I went back and thought a bit about it. I first tried a solution that had recursiveness in it. Didn't fucking work. Took up like 22 gigabytes of memory, and it failed. It never ran to completion. Because I was trying to take my naive part 1 solution, which was how do you say that? Generate all strings that match the rejects, basically, which was a lot for part 1, but it was fine for part. Sorry, it was a lot for part 2, but fine for part 1, because it was manageable. It's like 500 megabytes. I copied it to a set to do fast searching, and there you go, gigabyte of RAM. I was highly inefficient. What I did is I realized that the first rule was, hey there, Avenue, by the way. Rule 1 was 8, 11. And 8, was 42. And 11 was 42, 31. Meaning that any valid answer would consist of 42, 42, 31. That's easy to check, because after some checking, I noticed that every single rule path produces the same length. They're all, I think it was 8 characters long. And the size of them is also the same. That doesn't really matter, but the fact that they are of equal length is basically what makes this problem solvable with this approach. Because what I can basically say, hey, I know the length, so I know if I just break it up in 3 chunks, I can check each individual chunk against these rules. And hey, these 2 are the same, which means that I can cut it in half. So I only have to generate 2 rule searches. This is the unchanged code from day 1, by the way. Just generate 2 of these rule searches, and then I just check, hey, is the first bit correct, is the second bit correct, and is the third bit correct? And it works. It's great. Of course, part 2 was slightly more complicated, because now we had 8 was recursive. However, you can realize something here. This is the same as 42 plus. Any number of 42, and this is basically 42 plus 31 plus with no 11 in between, because that's the way it works. Because it will place another 42, 31 in the middle of this, basically. And these 2 numbers are the same. So what I would have is basically this block, which is rule 8, times x, and this block times y. And I actually slightly reordered what I basically say, okay, we have I of 31 and we have x of 42s. And because of the minimum viable solution is 42, 42, 31, which is 2 42s and 1 y. And for every extra iteration, I'm either going to add a 42, which will increase x, or I'm going to add a 42 and a 31, which won't increase the difference. And because the basic number needs to be 1 higher, 1 more x than y, I could check against this. So what I do is I basically keep taking off the y block, the 31 rule, off the ends, until I can do no more. And then I realize, hey, so that's my y, and then I basically calculate the x, and if the difference is, I basically do number 2 needs to be over number 1. If that's true, we got an answer. And now you might say, okay, but Nitro, they're both going to be 0 if nothing matches. That's super inefficient. You're just going to be checking. I just continue. I know the first block needs to match the first rule, the first bit. So if it doesn't, continue. We already know it's not going to do anything. What I can do then is, hey, I check from the back. If the first block on the back is not does not match y, then I continue, because I know that I need to have at least 1 there. And then I just check this, and there's no more checking to be done, because now I already know I start with an x and I end with a y, and now I simply need to count in between. What I could do is, if I find something that doesn't match this, to continue, but at that point I'm like already down to maybe 1 or 2 checks. So it wouldn't really be worth it. Anyway, the only issue then is that I have it off by 1 error. And it was really weird. And this is the one like caveat of my solution, is I don't think it works for every input. I don't know why, but somewhere there's an edge case. And what I did is that I tried to run it against Aftish code, and his gave me an answer that was -2. below my solution produced an answer -2, the real one. So I first got 385, then I checked 2 lower, and it said, oh, this is too high, 385, and 383 is too low. So I know my answer would be 384. It's a bit cheesy. I think there's an edge case somewhere that I have 1 of, and that Affish has 2 of in his inputs, and that I just snagged that on. I think it might be the basic one. I'm not entirely sure. It's a bit frustrating, but it was also 2 in the morning when I was doing this, so I couldn't really care. It runs in 2 milliseconds. My original solution took like 40 seconds. I think Dennis made one that ran in 20 minutes because he implemented a general grammar engine. It's like a CMK solution thing, kind of. But yeah, it works. I'm happy. It's super fast. But we're gonna be ignoring that because we're gonna be doing 20. We're gonna do day 20. So let's copy some boilerplates into main. I looked in my Discord. Everyone censors their answers there, which I'm very happy for. And I only look at those when I'm done. But I heard something about image processing, so if I can actually find a day that I can solve an image J, I'm going to be very happy. Don't think it's ever going to happen though, because I would need to mold the information and make a plugin and all that mess. Anyway, let's go start with day 20. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there was anything interested in the image the Mythical Information Bureau satellite captured. After decoding the satellite message, you discover that the data actually contains many small images created by the satellite's data camera array. The camera array consists of many cameras. Rather than producing a single square image, they produce many smaller square image tiles that need to be reassembled back into a single image. Each camera in the camera array returns a single monochrome image tile with a random unique ID. The tiles, your input, arrive in random order. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated, flipped to a random orientation. Your first task is to reassemble the original image by reorientating the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data... Oh, that sounds fairly simple. All tiles have this border, and the border lines up exactly when the tiles are both rotated correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. Oh boy. Yeah, the IDs are that. Multiply the IDs of the 4 corners together. So my one issue here is going to be collisions. Interesting. Oof. So my worry here is that some of these edges will have overlap with others. Sorry, as in there will be more than one hit. So what I can do is I can check if they're the same. That's what I'm going to do. I'm going to hash this and then then check it. Because this is basically a binary image, and I can convert this zeros and ones into a number. The only thing is orientation, because it can also be reversed. Interesting. I could make a hash that mirrors of something, because basically what you want to do is well, I can check in reverse. So what I could do is I could pre-generate those. I could generate like the 4 corners it would have, and then the 4 reversed ones. Since if I rotate this 180 degrees, this one will be flipped on top, and this one will be flipped on bottom. So that would probably be the best solution. So for every tile we generate that, and then we kind of go through all the tiles, so we need to find matches. And my biggest worry is that they're going to be overlap. But if you do that, you're just going to devolve into some horrible mess. So I don't think he would do that. I will build in a check to see if it happens, because what I can very easily do is check if there's 2 matches for anything. Let's first start with input parsing. So what we're gonna have is we're gonna have a tile number, which we need to save, which we'll just make into a map. So we'll make maybe a struct out of that, I think. So let's make a struct tile. And I think the width and such are fixed. I assume that mine has like way more tiles, but they're the same size. Yeah, this number of tiles makes me think that there will be no overlap. Otherwise it would be horrible. And you can still have a very large amount of unique tile edges. Because this one might not, no. Yeah, see, this one matches up here, yeah. Okay, so how do we struct this? First, we can just do a struct for the data, which would just be an array. Let's make it a, I can just make it a very naive array. So we just have like, and let's go. We will complain. Yeah, it needs a size, right? Yeah. So const int width, const int height. Equals 5. There we go. Stop complaining. There we go. Let's check the actual width and height. So it's 10 characters wide, and it is it seems to be 10 characters long as well. Yeah, 10 characters. So it's 10 by 10. It's good. And then what I want to do is I want to give it edges already. I don't think this data will actually get anything. So what do I want to do? I want to get a number, and I want to just make it numbers. So we're gonna make it unsigned. So the data will actually be fair. It will just be a bool because it'll just be true or false basically. And then what I'd like to do is have just 4 numbers. So I'd have unsigned ints. Actually, no. Don't make it unsigned. It's gonna be like 10 characters wide, and that will fit perfectly within the 32-bit data type. So just do int top int top r, and then just kind of continue on int bottom r, int left. Let's do west. Well, top, but doesn't matter. Left, int left, r, int right, r. So what I could do is I could hash this, make it hash it already. I just make a map, or a vector basically. But searching through a vector is slow. Sorry, searching through a set is super fast. Searching through a vector is slow. What I could do is reverse it to top. So the number that is the top will get 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And I think this will work fine. Because what I can do then is... Oh, there's no good way to iterate through this, is there? I should probably make it a vector. Yeah. Vector int, which we could just call size. We can have it size and size reversed, which means that I can then know if I need to flip it. Yeah, that's probably a better idea. I don't know if they're gonna be identical. I kind of will have to say they won't be. What I'll do first is calculate it with the vector, and then I'll change it to a set once I have my correct solution. Because then I can know if it still works, so which is called earth sides. There we go. And we'll make this top, but still go to go north, east, south, west. That'll be the order. And the reversed will literally just be the bit order the other way around. So now what we can do is we can do blocks. I might discard the data because I think the data inside is really irrelevant. And of course we'll need an int that is ID. There we go. I don't think we're actually going to need this. I'm going to keep it just in case I can uncomment it. But I don't think the information inside matters. It might for later, in which case I suspect 2 will be like, find the message that is hidden inside these tiles, but we'll think about that later. So let's go, so we're gonna need string, so string x, while, get line. Actually, this could just be string together right now. While get line, input comma x. And what we do is, so we know we started with a tile, so what I can do then is do like, thinking about this. So here I just want the number. I know already what it's gonna be. So what we can do is we make a new tile. So we do tile, tile. I think, yeah, you don't even need to declare anything. What I can do then is I know, so this will be the if there, because what I can do then is basically say tile.id equals string to int stoi of x.substring from it'll be the substring of the offset and count, so the offset will be 5, I think. So 0, 1, 2, 3, 4, and then 5. So that'll be 5 from the 5th character to, it's an offset. I suspect it'll always be 4 long. I'd be very surprised if it wasn't the case. Yeah, it's always 4 long, so I can just do 4. 4. I can actually do very simple. If x0 equals tile, because then I know it's tile. Any later processing maybe just do here, and I can also just do a quick of tile. There we go. Just seeing if this works. We've had early data processing issues, which I'd rather avoid. Yeah, so we need to exclude you from the project. Yeah, so that's all the IDs. And then what I can do is all the way else. Here we go. If we want to just have a vector of tiles, probably just have a vector of tiles. So what I can do is here, if x dot compare equals 0, we do tiles dot pushback tile, and then we do tile equals, I think it's like something like that. I know there's a way to clear a struct. We did it with day 4 as well. I just passport, so it's just tile. So I just do a tile. There we go. Default constructor of a struct is just an empty struct. So now we get a plain tile. And, And now what I can do here is actually say, hey, first of all, be smart, Nitro. Add a blank line to the end. And then here I can do like couch tile.id. So just to make sure that actually stays through and through, that should be alright. Good stuff. 2729 is the last one. 27. No, it's not. Oh yeah, that's because the last one will include an end of file. There we go. Alright, so now what we can do is we can do logic. What we can do is here do an else. Else. Hey. And now I know that anything now I know that here's logic. So what I'm gonna be doing is I'll do a short block of string. So this would be vector. So we'll do a vector of string, which is gonna be buffer. So this will just be our data. So just do buffer dot pushback x. And then here I'm going to do buffer.clear. Since I know it's actually 10 lines, I could also make it way faster by just doing like ints, do like a char. Or make it a string array with size buffer, like really. Although, no, let's not do that. Then I have to do indexes here, and it's all a freaking mess. Anyway, alright, so what I can do here now is do actually all the processing to get those numbers clear. There we go. Let's see, so what do we want to do is we want to take, for example, the first line, so and we want to convert it from, well, I can already do the processing there, so we do like a replace of, how did I did that earlier? I think I just did a check for if it's a hash or a dot. So let's see, let's do, string s. Then we'll do 4 const char c in buffer 0. What are you complaining about? No, that was it. So what I do then is if c equals a hash, s plus equals 1, else s plus equals 0. And I should already initialize this to 4, so I can already index it to it fairly easily. And I need to look back to, what day was it? The one with all the not you. No, this was the passwords. No, it was the one with the string mask. That's the one, 14. What I want to check is how do I make that into like a proper string again. That was it. 2u long. That's how you can do that. So what I can do then is say, hey, back to the type specifier. What? What? But haven't I done that before?
Mais c'est un robot. Que pourrait-il faire sans vous?
Il n'y a pas de limite à sa puissance. Il peut détruire la Terre.
Yeah, there we go. How does that not work? What are you on about? Will this not compile? Yeah.
You have burned so very, very bright.
Oh, yeah, so it wants, What? Why is it complaining? Syntax error constant.
And you have burned so very, very bright.
What? Expected a type specifier. Do you need to have like an int here? Still complaints. I mean, is it thinking that I'm defining a function? Well, I guess we just have to do that proper. Differently, that's what I mean. So I could do reserve 4 here, but there's no... I think it's because you're not allowed to do logic here. Maybe that's it? I'm not entirely sure. No matter. I'll simply do it from the proper order. I'll probably do north, south, east, west, then. Yeah. There we go. So now I simply do whatever we did here. So this will be a number. So what I do is sides dot pushback. Oh yeah. Tile.sides dot pushback. And then we do this. We know it's only gonna have width bits basically. And we're gonna do S, and we're gonna just make it a 2.2. Wait, there's only 2U long? It's only either an unsigned long or an unsigned long. Nice. Anyway, it's gonna complain because they're not unsigned longs, but it should be fine. And then what I do is do reverse. So can I do an s dot reverse? No. Let's see. CPP string reverse. Yeah, that's the one I want. Reverse. And then we just do dot sides r sides. That's r sides. Sides. And then you just do reverse, which will be s dot start, s dot end. Let's see. Cannot find it. Huh? What do you want about? S.starts. Basic string has no member starts. What? Oh, it's first of all, it's begin. That's why it's complaining. Because it can't find an over. What are you complaining about? Oh, it reversed it in place. Ugh. Why? Not that it matters. We're done with you here. So this should do those two. Yeah. And I'll make a function for this so I can just hide it away under the rug. Just be void fill info, and this will be a tile and a vector string buffer. And then I can just do I can just kind of ignore that all and just do fill info of the tile comma buffer. Because this is gonna be ugly. Because what I have to do is I have to copy this again, and then instead of buffer 0, do buffer height -1. Do that again. In this case, it'll be the southern one, and now we do let's do west, the first, and then east. So how do I do that? That'll just be a slightly different traversal. Because what I do is I do for int I equals 0, I equals is less than height, I plus plus. I'll actually do both at the same time here because I can do I can just make it a string weasts and string easts. And then I just do this logic. But the character will change for each of these. So E. I copy this as well. This will be W, 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 E, 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 E. And in this case, C will be buffer I 0, and the same will be here, but then it'll be width -1, and this should work in theory. And let's just kind of test this. So what I can do here is yeah, so what I do here is I'll just do count tile.id, and then what I can do here is actually do count s, and this will just give me the bits and the strings that I'm looking for. And there we go. And then once I've done that once, I'll just don't need to get a vomit here of crap. Just return 0. Let's see if this works. First tile. 2 1 3 3 1. So we're 0 0 1 1 0 1 0 0 1 0. Ah, that's weird. So you should be 0 0 1 1 1 0 0 1 1 1. First do this. So 0 1 1 1 1 1 1 1 0 0 1 0 and 0 0 0 1 0. So the good thing is we know that a unique combination of bits will be that it's just a hash as a word, that the stupid concept that I mentioned at the start. It works. And what I can do now is, so we've done everything. We have a nice little vector of tiles here. So now what I want to do is I want to do so I could have a so we're gonna have edge cases. In total we'll have well, it depends on the shape, because a square will have the least, so we're gonna have at minimum few dozen sides. So what I could do there is I could check for any edge. If it's even in there, how do I do that? Simple, we just make a set. So we set int. Oh, I need to make that a global or something. It'll speed it up quite a bit, especially for the larger one. So let's just, yeah, sure, let's do it this way. It's fairly simple. Can only do this. You know what? Nah, it'll be fine. What's the worst that can happen? It'll only have. It'll be an ON search, but an OLog N search is already so much faster. All right, screw it. Let's add it. So we'll have a set int of all sides. So this will be all of them, reversed and normal. So I know that it can't possibly be found. Oh, wait a minute, no, because it is going to add itself. Because, let's see. So a top and a bottom, it should match something that's not itself. Nah, screw it, that's way too much work. Fuck it, not going to do it. I'd have to do, like, I need to exclude itself, and that's the annoying thing there. So let's not bother. So one thing I can do is ignore if it's the same tile ID. So for tile T in tiles, I do another for loop, which is for tile other tile with T tiles. If T dot ID equals OT dot ID, continue, please. And then I'm going to be doing basically seeing if any of the sides match any of the other sides. And let's see. So say, can they match the same side? No, they can never. It should never match. Like a top cannot match a top. It needs to be a reversed top. But a top can match a bottom. So we'll do that. So let's say I want to know how many matches there are per side. So let's do for. So I don't care about its own reversed sides because it should match with a reverse side on another one then. So let's do this. So for int side in t dot sides. And then I do two for loops for int other side in OT sides. If side equals O side, out. Just do something, you know what sound that'll make in your mind. And then we just copy this again and we do it for the R sides. There we go. So what this will do is it'll take a tile, take its edge number, and then see if it matches. And we have an example here or something. Yeah, so this will give a unique number, and this should be the same as this unique number. And then I know, hey, the right side of this will match the left side of this. And then what I need to do is some kind of matching. What I know, thankfully, is that the corner pieces will only have two. So what I could do is have a simple say that says vector, even simpler. Just do an int sides side IDs of 4. So this will be so this is just kind of tell them if it's top, left, right side, and I know which one it'll be based on the original one here. So what I could do then here is say, hey, I will need to slightly change this up though. Do for int I equals 0, I is less than 4, I plus plus. Now we do side equals t dots sides I. That'll be an int. What are you complaining about? What do you mean, undefined? Oh, I'm stupid. Oh yeah. And then what I do then is basically say, no, simply do count t.id, so I can know they're unique. Then we do a side, which will be I, and then we do ot.id. So this will tell me that, and then it's actually I'm really not a fan of. Yesterday was kind of alright if you figured it out. Just to finish this train of thought before I talk more. T dot side IDs I equals ot.id, and we should never see this duplicated. This should never be the same. These two should never be identical. We'll see now if that's the case. Where? T sides I. But that should have 4 sides. 1, 2, 3, 4. So first of all, I think I already know what the error is. That's not it. Let's see. It's Caravan Palace stuff. So there were errors at the start? What? What are you on about? 9 tiles. Good. Hey, that doesn't work. Fill info tile buffer. Well, that's not right. So the ID gets done properly, but the sides do not get filled in at all. Here. Yeah, see? These are empty. Why? Tile. Something goes wrong with my data crap. Tile buffer. That's strange. So what happens is, okay, so we know that pushback X, tile ID, that works. I think it might be that it just retroactively clears it or something? No. Because when it pushed back, you copy the data. Because you do tile, not tile. Not that it'll work, but because it contains the actual data, it's not just a pointer container. Fill info gets called. I can move these again to see if that works. Actually, no, what I can do here is do a quick... out tile dot sides read, just to know, because this should already error out now. Yeah, good stuff. So we know that this is where it goes wrong. So sides, does it like return here or something? So just retry. Now we should see this line show up. We do. So it does that all proper. Tiles.arse.size.pushback.
Brother, what you thinking? Leave that on record spinning. You'll feel the rhythm going. Legs ain't got time to lay low. Your knees are bending, so it's time to get up and let go.
This works. So the oolong T might not work. Note that this data type is not oolong, it's int, but that shouldn't matter.
It's time to get up and let go.
It's like pushback doesn't work. But why are you grayed out? Oh, you're a parameter. Yeah, tile. Oh, huh. So it still works here. It's just some returning crap that doesn't work. That might be it. Just... I think it has to do with some weird crap with regards to how long the data actually persists. That's really, really weird. I wouldn't even need to do that. There we go. Then I wouldn't even need to do this technically, but I want to keep this just here to make sure that it works. That seems to work. Great. Yeah, so that was the error. That's a weird one. Some weird data persistence stuff. Anyway. Alright. So, nice and readable, Nitro. Well done, as usual. Alright. Let's see. So what I want is for nowhere to be the same number. Well, this seems to work fine. 3. Yeah, so I think it's my guess you guys was true. So now it's actually going to be really easy to actually do this. To do part 1, I think. What I can do is have another, and that's called filled sides. And just, and just do int answer. And then at the end of this tile, oh yeah, by the way, I already see the, I already see something here. First of all, I can't type. Second of all, we need some 9s. Nice. Some nice unsigned long T here. And this should actually already give us the answer for part 1. Sorry for our test stuff. Which is 20899 yada yada yada. Great. And just remove these counts. Your typing skills are great today. Look, nothing I ever do is great. You should know that by now. Just need to make sure, yeah, 2 enters on the end. This should be part 1. I think you guys are already done, right? Oh, that's over. That looks like overflow to me. Oh, that's the right answer. Great. Sea monsters. Hey, I wonder if I need to search for that. The borders of the tile are not part of the actual image. Start by removing them. In the example above, the image has become this. Remove the gaps to form the actual image. To search for the sea monster, because your image monochrome, a sea monster will look like this. The spaces can be anything, only the... okay. Holy fuck! That's gonna be something. I can do this in ImageJ in theory. I know how to make an image from a data array, but I don't know how I'm gonna do like a find pattern thing. Oh my god. How do I do that? Obvious how to do it. Yeah, I can brute force it. I don't want to. Do it manually, right? I know a way to brute force this. It's not very complicated. Look for the line that matches the... So... what I can do is... so... I don't know what the actual size of my image will be. I think it's going to be large. Pretty large. So what I could do is I could convert it all to huge strings and then search. Basically search for... what? What do you mean? So how many IDs are there even? I didn't even count. It's 144 tiles, so it's 12 by 12. It's not impossible. Let's see. 120 by 120. Yeah. 12 by 12 tiles, and each one has, yeah. You can do them manually, basically. My idea, stupid idea, would be to concatenate it all into a huge, like 120 character strings times 120, and then basically try to find this pattern there, and then see if the appropriate sections below and above also match this pattern. I could do this with numbers, but 120 over 8 that wouldn't. I would need a 128-bit number. I think that's a U long. What is unsigned? I think it's like 128 or is it 64? 64. Yeah. Just do it manually. Do I want to? I agree with Hamster. 120, 120 array. Seems pretty easy to do. Yeah, exactly. But I don't want to do that. I am not very good with pattern recognition in images. Check all hash tiles if they are left part. That's why I didn't do this. Yeah. Because you need to do an offset thingy. Well, no, what you can do is just search for matches with rejects. Just use rejects. just use rejects. Okay. I just want to do a quick theory, right? You'd just be giant, right? Yes, I think we're gonna reject this. Look, I can just do what is it? 4 1 2 3 4 1 2 3 4 1 2 3 4 5. Wait, no, what was it? 2 3 4, yeah. Oh yeah, they don't have to be dots, so they can be no, you're correct. It can be hashes as well. So this needs to be 4 of anything. Don't really care. So it could just be so we do that this way. Hash dot 4. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why is it not working? I could just also escape it. What do you mean doesn't exclusively match full stop? What? No. No. Exactly, it can be anything. Yeah, I know, I could just do it like this. I know. I just kind of wanted to do it the proper way, but it's not working. Because we should have a match. Wasn't it a match here? I need to actually get this. Is it rotated the same way? Yeah, it is. I did know. That's why I escaped it before. It's like 4 times, right? Exactly 3 more of A. So one that it should match is hash. Because it was a hash, because it was like a hash or a dot. 1 2 3 4 hash hash 1 2 3 4 hash hash 1 2 3 4 hash hash hash. It can have anything at the start or at the end. I know there. I know Baz. So it can have anything at the start or at the front. But of course it'll just match that. So how do I do that properly? Wasn't there a way to tell it doesn't have to match the entire string? No. I think it's possible to search within a string, because that's why I have these, but... Huh, so that's the part that messes it up. So as soon as I add another hash, it will fail, of course. It's no longer oh no, wait, what? So... Wait, what? So why is it not matching... Oh, is it because there's something at the start? No. So why is it not matching the other stuff? That's weird. Oh, after flipping it and rotating it in the appropriate direction. So I think it's flipped somewhere. I think that's the issue. So I just do a quick substitution of any O with a hash. Yeah. And there we go. Yeah, so there's 3 that match that. Oh, could I... Could I just throw a regex on this? Just make 1 regex to match it. That sounds like an idea. Let's see. So what we're gonna have is we're gonna basically have. But this will just be 1. How many will this be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19. So then there's gonna be something, we don't care what, there's gonna be a line break, so there should be a line, like an end of string there. And then any number of characters. I knew you that you're all drug addicts and my drug is rejects. And I can't deny that really. So if I just remove this, it should match. Matches a lot of stuff, of course. No, the issue is, of course, it'll match different spaces. Yeah, I see. Nah, this won't work. Shoving right up. So one thing we can do is find everywhere this is, and then kind of search around that. I think that's probably the best idea, because here we know, hey, there's one here, and there's one here, here, or here, and then we can check the line above it in the same region of 20 characters. Is it the width that's actually correct? Yeah, so this is also the widest it can be. We're gonna regex, kids. I hope you're looking forward to this, because I'm not. Okay, so we do actually need to get the data in there. It's fairly easy. We just have vector string buffer. So this will be data. Because what I can do here is do for string s buffer. We do result dot data dot pushback s dot substring of 1 comma s dot, this will be width, which will be 10. Is it 10? This 10. Is it 10? It is 10. Good to know. So it's 10 minus 2. And now we'll have our data. So what I can do then is actually start orientating this. How I do that, I'm not sure. So what I could do first is find a tile by ID, but then I need to know which side it's on, because I don't keep track if it's reversed or not. So let's first see if we can stitch that together. Let's see. What's probably the best way to do this? I could keep a simple boolean that says if it's reversed or not. This is in theory all the information I need. The only issue is chaining it together, because if A and B are mutually not reversed, but B and C are, then everything that comes after C needs to be reversed as well. So we just do that as a flip. Oh yeah, just do it line by line. I think that's actually probably the best idea. So what I do is I basically have 120 strings. So we'll have string picture 12. No, it's 120. 10 times 120. I could actually do this in ImageJ. It's very easy to turn data into an image there, but I don't think you can just tell it to, hey, stitch this together in some way and it'll just do it for you. I don't think it can do that. Anyway, so I need to start with a corner. Just do the last one. There we go. So we'll do last corner. And what we can do is do last corner equals t.id. So now we have an ID to start from. So these are alls that only have 2 corners, so 2 sides filled. Counts. Let's do something quickly first. For actually, we just have last tile, basically. That'll make it easier tile. So for last corner, dot sides, int I, int sides, side, whatever. Because actually stitching this together is not super easy. Well, that's the side ID is I need like filled sides basically. Oh, what? Oh, I need side IDs, of course. There we go. Up, down, left, right. Up, down, left, right. Hey, down and right. That's really nice. That means I can start from this tile very easily. So I don't have to rotate it or anything. So down and right. Because it is north, south, west, east. North, south, west, east. Yeah, south and east. So it's bottom and right. That's great. Which means we can do this very easily. So what I can do now is do data. So for string s in the data, we do actually just do better. So we do for I equals 0, I is less than height. Just do height minus 2, I think. Oh, height minus 1 plus plus. And then I do picture I equals last corner dot data I. And then I need a function that just says print. So what we can do is do very simple for s string s in picture count s symbol. There we go. So this will simply print the first tile. Or it won't. Oh yeah, because there's 120 empty ones. Duh. Doi. There we go. That's gonna be large. That's gonna be very, very large. It's 120 by 120. So what I can do now is actually start attaching the stuff below it. I am gonna quickly actually, before we do this, I'm gonna make this 144. And I'm going to remove this width minus 2. I'm gonna make it width minus 1 and 0. So I can check if the edges match up. So this is gonna be fairly simple. What I do then is I basically go to the corner below and check if it's so let's make it last tile instead of last corner. And now what I can do, I can go down. I take the one that's in the south position, and so what I can do is basically do last column or something. So let's do it a bit wacky. So tile will be column top equals last tile. So this is basically going to be a bottom to top writing it down, because that'll just work better with my mind. Go from left to right is probably better for memory access. Actually, let's do. Let's do that. So we'll do. It'll be row left. So row start, basically. What I do is I take the one that's to the right of this, and I see if it's reversed. So I have a bool that says, bool, are we flipped right now? And of course we start out false, because we checked it. I could have done it the other way around, doesn't matter. And then I need something to rotate data. Let's see, so we'll need a vector of string. It says like rotate. It's like rotate strings or something. Yeah, this just rotates the elements within a range. I don't care about that. Yeah, see, I don't want that. Rotate a string array? Oh, here we go. Array rotation. That's what I want. Of course, because I don't care about that. We just rotate this. No, I want a 2D array. Rotate 2D array. There we go. There we go. To do some mirroring. For n to 0, yeah. So we know it's square, so in theory this shouldn't be too difficult. So we just create a new bum. Yeah, this is basically what they do. Row -1. Yeah, n+1. Yeah. To n-2. So why n-2? Because we're not doing transposing, but well, kind of are actually. I'm sure that other languages have like better crap here. So to rotate an array, let's just do 90 because we can just repeat that. Kind of do what they do there, yeah. Because if you have like a square, the line here will go like. And then the line here will, just do that. Screw it. Oh. And then I simply do now let's do it like the other way around, so that I don't have to start at the end of the string, as it were. So we just construct the strings of results, yeah. String s equals nothing. And then I do results dot push back s. And then I do for so the width becomes the height becomes, it doesn't matter actually because they're the same here because they're square. It's the only way this works. So what I would do is have a so the original width becomes the height, so the original height becomes the width. But I need to construct a string, and that depends on the height. Yeah. I minus 1. No, it's height. I plus plus. And I just gonna do this for OS, original S, in the buffer. Return results. And here it's just constructed. So what we do is, oh no, for int I equals 0, I is less than width, I plus plus, and then we make this to j. And we need to do u. There we go. So s plus equals buffer. These lookups are gonna be slow as fuck. I maybe should make this an array. Can I make that an array? We already know the size, so it's not very difficult. So we could make this. I mean, I already make this an array, so why not make this an array as well? Not very difficult. Well, I'll do that later. Screw it. Buffer. So this needs to be done properly. So normally it would be ij, but we need to do ji. I'm just gonna quickly check this in my mind. Yeah, because what we want to do is we take the first character of the first line, then the first character of the second line, the first character, etc., etc., etc. And I can actually, we need to reallocate memory anyway. And then result push back and do result. So what I can do is fairly simply see if this works by doing vector string rotated equals rotate of last tile dot data, and then I basically do this, and instead of do rotated, and instead of a 0, well, what I can do is do plus equals, so it'll get added onto the side. Let's do space here. There we go. So for the rest of today, by the way, I'll be after this stream, I'll be taking a rather. Okay, that didn't work. Why not? I'll be taking a break. I need to do some cleaning. I need to do some shopping. I need to do some other stuff. Maybe I'll be back tonight. I'm not sure if that works. Yeah, that seems to work. Well, I guess we don't need to do this. I think the issue is because it also... Wait. How come you are not as wide? Hey there, C-Fusion. Does today suck? It's interesting. It's interesting for sure. Yeah, that's so now that works. This was one off. So what I want to check now if it's actually so the top one will be the rotated one. Working on my exam. Yeah, they're really nice. I preferred that one much more as well. That type. So just do a quick counter at the end. And we'll take a look if this worked. Today's kind of alright. I like image processing, so I'm curious about the data structure management here. So what we want here is for this to be the flipped version, rotated 90 degrees. How can we check this fairly easily? First, to know what kind of thing we did. This is my specialty, so I like it. No, it's much. This is not my specialty. Because I don't work with stitching together crap and rotating in the middle. Like, if I could have started this day in ImageJ and have had a small amount of things better. Like this rotating, one line. I know instantly how to do this. But like the logic for stitching it all together is much more complicated, and I don't think it even has feature finding in it either. So as far as I know, there's no easy way to cheat this day. Truly cheat it. Let's see. So one thing I can really see, my large line of ones and zeros. Don't know where the fuck that came from, so that's already wrong. I also see that we're not doing all lines. That's strange. Oh yeah, it's because of this. That's why. No. So this is because we need to chop off the ends. Yeah, so that makes sense. Yeah, there it is. What? Okay, the mirroring went a bit weird. So you can see this line came from here. But it means that this corner went to there. Which is actually what I just did before. Let's see, how did I do this in my logic? So the first value should be the same, 0, 0. Yeah, so the first line is constructed of the first values there. It's exactly what I thought. And then it goes, yeah. But this is not a rotation, strictly speaking, I think. Yeah. Yeah, you know why this isn't a rotation? It's because I'm, yeah, I already know why. So, if I want to construct this first line, the first value should actually be this one. So what I should do is it should be height minus j. Well, height minus 1. And let's test it now. Yeah, that works. So now we rotated it 90 degrees clockwise. Perfect. Yeah, I think that worked. Yeah. So this is now rotated 90 degrees clockwise, and we just kind of keep doing this. We want to rotate it more. The thing is, they're only always flipped 80 degrees, I think. But it's with this we can do anything. Just rotate it more times. If it turns out I need more of one part, I'll just make it better. If I have only 80 degrees something. So now we do is we go to the next tile. So what I can do is actually do 4. So first thing we need to do is actually reinstate that that thing we did before, and this needs to be -1, and this needs to be -1. Oh no, so this needs to be, this is, but so it's because you need to discard the first and last character. So you go from 1 to, it needs to be an offset. So you can't, width just takes all the characters. We need to go to width -2. I'm pretty sure. The substring is not as easy as you'd think it would be. You can't just It's much easier in Python, for example. So substring, it goes from the first character to width, which is 10 minus 2, so 8, and it should go from 1 to 8, and indices. This goes from 0 to 9. So this, to my brain, looks alright. I'm still gonna do a quick count here. One. Yeah, that's 4 by 4. And that is... That's not correct. I know why. It's because we need to discard the first and last string. So, for int I equals 1, I is less than height minus 1. Yeah, so we see this come back as well, I plus plus. And then I just make this is buffer I. What's going on? I already saw that line there. There we go. Picture I, and now you need to be minus 1. Of course. There we go. I also already know a way to index this way faster. Wait, what? No. Oh, of course, because it's gonna be shoving it 1 up, so it needs to be minus 2. There we go. Perfect. So if you haven't seen today yet, we're searching for the Loch Ness Monster. Makes a lot of sense, don't worry about it. I'm now gonna actually change this to an array as well. I don't... the data itself, I'd like to be an array, because this will make indexing so much faster. Minus 2. So here we can just do result.data I minus 1 equals, and this should just work. It just works. So now it's array, so it's much faster to traverse to. So this is an add data. And the good thing is I can add it on by just taking the same index and just tacking it on. So now we're going to do some logic. So we're going to do this for int I equals, which is going to be the width of all tiles. We know it's 12 by 12, so it's going to be 0. So we're going to be like tile no equals 0. Tile no is less than 12, and do it plus plus. And this we need to do for, you know, this. So this last tile is where we get the data from. So we're going to change that. The first one, so we're going to do it like what would be the next tile. This is a bit clunky. So oh well, it's fine. So what we do is so we take this last tile, we check what's the tile on the right. So that'll be our third index into our sides. So we're gonna do int next ID equals last tile dot size 3. So it's be the ID, and now we need to get the ID. So we'll just do a simple function for that, which would be like tile get ID, tile vector tiles, tiles, new for tile teen tiles. And of course the int id. If t dot id equals id, return tile t, and if we don't find it, we do could make a map out of this actually. So let me make it a little bit easier. So we can do a map that has ID, yeah. Because we don't use it anywhere else before this. So let's see, CPP iterates map iterate over values. Oh, well, that's easy peasy. Because you just do here using pair equals pair int comma tile. Huh. Interesting that it allows this to be back referenced. Because we just do pair p and we do t tile. So we just do a p dot second. Constant int? Sure. There we go. Same here. Pair OP. Pair OP. And just do this. So it'd just be OP dot second. Actually, this will just be OP dot first. Nice. There we go. OP dot first. Easy peasy. And this will be OP dot second. And here I just make this OP dot first. And this will be the same, will be OP dot first as well. So first things first, this should now work the exact same. And this will just be fairly easy. Oh, we need to actually return that. Just slightly more annoying. It should return an iterator. So that should be like we don't even need this because now we can just do it get ID. So we just do next tile. Let's do tile dot. Let's do int next ID, and then we'll do tile next tile equals tiles dot find next ID. So this I fucking hate these things. So annoying. Go away. CPP map. I know it returns an iterator. I just want to know how to exactly use it. Yeah. Second, that's the one. And what I can do then is basically make this our last tile. So I'll do this. But I need to know if I need to flip it. So how I can do that is so flipped means that it matched that side. Oh, fun sickles. I need to mirror it as well. So we need to do some mirroring somewhere too. Why are you complaining here? Identify T is undecided. No. If P dot seconds. There we go. And then yeah, you need to be. It'll be P dot first. And last tile will be P dot second. So, actually, let me just make sure we get the same answer. Return 0. Let's return to monkey. It's funny because we've been standing out for about we've been playing for about, sorry, streaming for about 2 hours, but it doesn't feel that long. Tile undeclared, yeah, that's what I thought. Strange how it only errors at runtime. And there, it's the right answer. Good. So, return 0. So now it's the difficult part is the rotation of the things. So, could you do that, please? Yeah, there's no. I need to do this myself because what we need to do. So we have side A. Right side up. So we know that it matches tile ID irrelevant. It matches the top side and it wasn't flipped. So if it wasn't flipped, we just rotate it 22 and 70 degrees and it's right because rotation just takes the number and that's the same as rotating. It's like there's a direct rotation. If it's reversed, it means we need to first mirror it around whatever axis it's on. So if it's like, because we always know we come from the same side, the left side. So it was like a bottom, for example, and it's not reversed. It's not flipped. We just rotate it once. Oh, I never said which side it matches to. So I need to do like a matched side. Yeah. Yeah, we do need to do a matched side. That's annoying. I could look through that. It's not very difficult, but it's annoying to have to do it twice. Anyway, so let's say we know that. We know it's the bottom. Then we rotate it that way. Yeah, because it just checks the numbers on the side. Actually, let me think. Oh boy. Because I do the numbers from top to... For the side, I do it from top to bottom. If it matches the... If it... Oh, so yeah. So if it matches... That's the first digit and that's the match. So yeah. So if you just rotate it, it works. But if it's flipped, so if this one... if reversed is true... I should actually probably set this to false as well. Just so we don't get garbage data there. Then we need to flip it, yeah. So if it's flipped, we just need to flip it. So we also need to find the side that it's connected to of that one. How do I do that? Well, I could have the side IDs be a pair instead of... Yeah, let's do that. So just make it a very simple two-dimensional array. And it'll be... Yeah, so side IDs will be a little bit more complicated. That's fine. So side IDs... will be... a pair. Yeah, so it'll be a pair of ints. Set it on, yeah, it's allowed, and I'll just need to know. So this will be comma 0 just for now. So now what I need to do is just do an index here. It's fairly simple because you just do for ins side nd 0. This is a lot of code writing to actually stitch this together. Good grief. More than I thought. Side ID is less than 4. I++. So we just throw this in here and we make int o side equals yeah, basically u, and then the index is I. Fairly easy. And then we just make I here. There we go. So it's like it's I divided Cyberman, see? And we kind of let's see. So what I can do is fairly simple. Just do the other if, and then I do o side equals yeah, there we go. Because if it matches this one, it will never match the other one. There's only ever one match. So what I means now is wait a minute, this logic is slightly identical. Anyway, I'll just leave it like this. So it's going to be north, south, west, east. That's going to be the connecting things. So now what I can do is see how I need to rotate it. And that'll also have influence on where I need to connect to. Fun sickles. Thankfully, I only have to do this once, because I now know that I could just determine what's the next one we need to connect to, because we always want to connect through to the left. But say if I rotate it, of course, it'll change what the next one is connected to. But I could just have an incoming ID and an outgoing side. So this will be ingoing side, which will always be 4. Because we'll always want to get the third one, go from 0, 1, 2, 3, like that. I'm gonna take a quick tea break. I'll be back in a second. By the way, just for reference, the leaderboard's close at like 1 hour 30 or something. So me taking this long is really not a surprise. All right, be back in a sec. Alright, I'm back here. I'm sure some of you have already noticed, I mean. But I posted a poll on my Discord about some games to play over the winter holidays, because why the hell would I do anything but play video games? It's on my Discord. I implore you all to vote for 2 or 3 games that you like the most or would like to see the most. For some godforsaken reason, the most votes currently are for a fucking Nep. For a Hyper Neptunia game. I got it once, a long time ago. I got it gifted as a joke. And I really don't want to play it. I just threw it on there as a joke. Like, surely. I mean, I can just decide to just ignore that option, but Jesus Christ, why would people vote for that? It's awful. It's just awful. Like, there's 2 clear joke options there. Factorio and Nep. But of course you would vote for both of them, Fusion. I give you money, clearly I can't. Bennett, you give me money to play 7 Billion Humans. If you want to see Nep, then tell me to play that in your slot. Anyway, let's carry on with this. No, that wasn't. But I don't. Jesus Christ. Do I even have it installed? Got one. I don't even know if it's a good one. Never played it, thank God. Please just veto that. This is a hell of your own making. Doesn't this look great though, but fucking kill me. Thankfully, I set my stream to 18+. We'll see. I just hope it kind of falls lower and I can just ignore it, but we'll see. Anyway. So first we need to rotate it and mirror it if it's flipped. So we need to make a mirror. We need to copy this basically and do a mirror. Call it a mirror. How many IPs can I spoof to inflate the vote? I really dislike having to. I really dislike turning on that captcha crap because it can take way too long. So just please don't. I don't want to suffer through that. Anyway, I think I actually made a mirroring already, but I just made this J. Although now it's a mirror over the diagonal edge, which is not what we want. Because I want a mirror in place. If anything, I'll make you play C blocks. I would rather do that than play Neps. Let me think. So now my question: do I need to mirror over the axes? And I think I do, because if I mirror over. Yeah, they need to mirror it over the axes that what we have, which so there's only 2 possible there. So we just have an full horizontal. That's fine. So that means I just need to determine what way the next one's going to be orientated. Because first I should rotate it and then. If I just always rotate it to be already properly rotated, it doesn't matter because, yeah, that's actually fine. So we just don't need a bool here. So first what we do is we rotate it. So, let me think. So the next idea is always gonna, well, actually it's gonna be ingoing. It's gonna be, this is not correct. It should not be. Let me think. So let's say it this way. So we know the next one is going to be there. It's orientated north side up. The next one can be any orientation. So we know the ID. And wait, size incoming ID should be a pair, right? Yeah, side IDs. Side IDs. Yeah, it should actually be side IDs. And this will be, sorry, this will be dot first. There we go. So the second number here, that is the number, that's the number basically that tells me yeah, so that's the number that tells me what side the connecting one is on. So if it's 0, it's connected to the top. If it's 1, it's connected to the bottom. So if it's connected to the top, we need to rotate it 3 times. If it's connected to the left, we need to rotate it 0 times. So that's going to be fairly easy. So what I can do is, so if next ID dot second is below, oh, that's a really annoying number. So if it's 0, rotate, I need to do some kind of data buffer. So we'll do data. So we'll do next data. Yeah, let's actually just do a data set here. So then I can make it easier. So we'll just do vector string how do I define that? I'm not using regex yet. I first need to make the damn thing. Yeah, string data height -2. So we'll do cur data equals so there'll be last child.data. I'm sure I can't do this, so don't worry, I'll fix that later. And then we just make it this, because then what I can do is I can set cur data to be like the next tile. To be like next tile. It's gonna be next tile dot data. No, you can't do this again. So this just prints. This just adds it on, because they're gonna be empty. I assume it initializes it as empty strings. I could check this, but it would 0. I'm pretty sure it works this way. So we'll just do it quickly. Oh, it might error out of compilation. I don't want to do that. Oh, come on. Alright, so copy string, or so this is the wrong freaking page to do it in. There we go. I should really use this, actually. really use that actually. Yeah, sure, let's just use that. I've been meaning to start using that for a while. So how do you do that again? So do like array. String, comma, t size, which we hide, -2 data. And now I can use it. And now this should will work fine. Yeah, and now I can do this. So that's extremely easy because it all has the same crap underneath. But this should be this, right? Yes, exactly, because we need to initialize that properly. Array. Just need to copy this, basically. What are you complaining about? Incomplete types not allowed. What? Array string, comma 3. What? So what's going on here? Do I need to initialize it? Because that will not work. Incomplete type is not allowed. Field error type tile data. What? Let's see if this works, but more below. Local variable is not initialized. But it won't help, by the way. Go away. Oh, stop! Freaking Google, man, you piece of trash. Here, inst, comma 10, my array. Why does that not work? Like this, fill. Am I including the right one? Ah, that's the issue. There we go. So now we can do this assignment, which is a lot better. This Max guy saying the poll is full of terrible choices. What a guy. All right. So we have the next data, and now what we're going to do is, if it's 0, we basically want to rotate the data twice. So we do like cur data equals rotate cur data. So I can probably make this already iterative. Oh yeah, it needs to actually work on an array. But that's actually really simple to change, thank God. Since I always know the size. Oh, with this. It's awful. Oh boy, I love it. What are you complaining about? Really shouldn't matter. So this is awful. So the way I can fix that is by just making it a constant somewhere. I don't want to right now. Fix that later. Let's see. So what I should do is make rotates and like that. So we do rotates, buffer, and do like an int rotations, and then what I can do is no, not yet. I'm being extremely slow. I also took a break in between, to be fair. So here we do if rotations is above 0. Well, actually should be above 1. Let's say there's like extra rotations. So, and if it's above 0, return rotate results, comma, extra rotations -1. So once I did 1, it should say, okay, hey, let's rotate it again, and rotate it again, and rotate it again. And yeah, once it's below 0. Sorry, once it's 0. So what I can do here is to rotate, comma, 3. This is gonna be super stupid. This needs 1 rotation. And then there's one more setting, which is gonna be if it's 2, because it goes north, south, west, east. So if it's 2, it needs nothing. And if it's 4, it needs 2. This totally makes sense. Don't worry about it. There's no fucking way this is gonna work, by the way, but we'll see. But we shall see. You know, I'm sure there's better ways to do this. You both rotate and flip. Flip is another function, yes. Because I keep, so what I can do here is like, if, what was it again? I have a variable for that. It basically gets set here. Here we go, p_second.reversed I. So I just do, that's the tile. And then it basically needs to, no, we need to go back to the first tile. But we still have our old tile, right? Yeah, we have last tile, which is no longer defined. Last tile? Yeah, that's the last tile. We're gonna redefine this later on, so don't worry. So we'll do like if last tile. The reversed, this should be the ingoing side. Let me think, because we basically mark, okay, I should probably actually put that here even, if it's reversed or not. Yeah, why not do that? So this will tell me the side of this, and this will tell me if it's reversed or not. So let's do that. So what we can do, we make it a tuple. Make it a bool. And this will be false. Oh, This will be true. And I think there we go. How do I index into a tuple? Like 1? Oh yeah, it's get. That's the one. That's the one. There we go. And now what I can do here is simply say if get to next ID cur data will also mirror cur data. And now we need to actually write that. So because we rotate first, we always know we're going to be mirroring over the same edge. Let me think here. So mirroring so it'll always go from like left to right here. So the right tile, we now rotated it to be the correct side. But if it's reversed, we need to mirror it over that horizontal axis. So this algorithm here is wrong, by the way, don't worry about it, it needs to be replaced. So basically what I would do is I would go line by line, and I would... Okay, let's just replace the first line with the last line, for example. So yeah, that's fairly easy. So we just do... So we already have results. I could hard code this, by the way. So what I just do... So with -1/2, so it's basically going to be 4. We're hard coding all of this anyway, but sure. Over 2, and we'll do results with minus equals buffer I, and basically the opposite way around, which will just be I equals width minus. This is not correct, I think, but I'll need to think about this for a second. Let's see, the width is going to be, so first of all, it should be height. Not that it matters, but hey, you know, just in case. So we have a height, which is going to be 10. So that'll be, make it 9. So first of all, this should be -2. Should this be -2 as well? Oh, no, because, yeah. Oh, it's just a little smaller then. So it'll be 9, it'll be 4.5. Just fine, because we want to go from 0 to 4. And in that case, it'll also work with odd ones. So this will be 0 to 4, and this will be -1. Right? So it'll be... And this needs to be -2. Oh, I need to technically I need to cast this to an int. But, so like it'll be, the intermediate will be like a float. So we'll just make it -2 to make it work for here. So we'll start at 8, and we'll go 7, 6, 5. Yeah, 7, 6, 5, 4. 7, 6, 5, 4, and then 1 was 0, 1, 2, 3. Together make 8 lines. So that's the mirror around the same axes. So now we have our data as mirrored, our data is properly done. We can go to the next one. Before that though, we need to set last tile to be next tile. And this is just for one row. And then we need to do it again. So we do 12 times. We'll see if this will error somewhere. Or it'll look horrible. Yeah. So first thing I want to do is I'd like to take my test input again. This should actually be fairly easy. Then we stop. Can't save when it's running. Retry. There we go. P-second sites. I. Let's see, where are we? So you're indexing, but complaining about indexing to the connecting one, which is the other side, the other pair. So side is going to be p-second.sides I. That works for inside ID, because you need to be side ID. That's why. It's because you need to be side ID. This needs to be I though. Wait, does it? Let's see. I is going to be my side. Yeah, and this should be side ID. There we go. So I did do this wrong. There we go. Retry. Shouldn't it have the same error though? What are you waiting for? Oh. Yes, Nitro. Well done. You just let a small infinite loop sneak in, yeah. What was the error? Cannot dereference the end of list iterator. Which get triggered here. Ah, yeah, of course, it'll fail. So how do you do that? So we'll do like a, oh god, what it's gonna be? It's gonna be unordered map of an int, comma, tile. Iterator equals this. Oh, and then it needs to be like it's the name. And then what I can do is if it does not equal tiles.end, sorry, if it equals tile.end, otherwise you're going to be second. So if it does end, continue, break. I think break actually. So now this should, in theory, still give us. What I want to. No, give me something slightly better. Count tile node. I need to know when you do this, because I know when this should happen. Tile. No. Oh, actually, I can just check if it's like the default initializer. If it's like below 0. So this is actually fairly simple. So let's stop this. Good that I can write it though, at least sort of, because I can simply check if the here if next ID is below 0. Break. Easy. Sorry, next ID. It's like this thing. There we go. Because it gets all initialized to all ones, I think. Although it's this strictly might break on someone else's machine if they have a different CPP thingy. So what are you complaining about? So what is... First of all, that seems... Oh no, it's test status, right. Next ID, I want to know next ID. 00 false. Oh, yeah. Oh, I guess it does get properly initialized to zeros here. Huh, well, sort of failed. Oh, yeah, I don't know why, huh? So why are you not working? Huh. So this should work, because if this works, it'd be fairly simple to do all the other ones. Well, let's first do this and make it 120. There we go. So why are you complaining? So this will be fairly, so we'll do this, which will be picture I plus. So what are you complaining about? But shouldn't an index... Oh. Cell's not 144 lines, but there we go. So this should work. There we go. Should work. So you only happen once. Why? Because you get immediately break. Oh yeah. I already know why. It's because our starting side is probably not going to be right. That's actually fairly simple to fix. He says fairly simple to fix. I can sort of force this testing by knowing which tile is going to be top left, which we know it's set right here. Here we go. So this is going to be the ID we need to look for. So here, instead of this, I just do so do like here, last tile equals tiles.find second, and now it should work. Because now I know that the tile we start with is top left. Still doesn't work. That's very strange. Let's breakpoint right there. Let's see. So next ID 00 false, that's wrong. So last ID, wait, incoming side should be 4 actually. Yeah, I think that's the issue. Oh, and then we need to fix incoming side as well. I forgot about that. So yeah, you can see here the side IDs are all empty. No, because this is 3. Yeah, because it's the last index. So why are you all empty? That's weird. Data, that's proper. That's its own sides. What? It never gets anything filled? Let me see. So we have our own tile P. Then we check it against every other tile we can find. I should actually do a sort of continue if they're all filled, but no matter. Actually, no, we can't do that. So then I get another tile. Then I check for all my sides. So I is my side. Inside is it's going to be this value here, which is like the number of our side. Then I check for the other side ID for the other guy. Other side is OP second.side side ID. That's correct. If they are the same, side and O side is good. P filled second like that, and then we do P second IDs, side IDs. So what we're looking into right now, right? Side IDs, yeah. 3, because that's the matching side, which I have none here. Is op.first, which is that's our other tile, the ID, the side ID, so that's the 0 to 3, and then false, yeah. But it doesn't fill anything. So that's weird. Let's see. Other side is OP second at our side, so that's the reversed ones, and we check that as well. And that should be the same, but why do you not get filled up at all? Can you show me all the tiles? So tiles, 9 tiles, a random one, second. Yeah, side ID is all empty. Why? Because second filled P second dot filled size is also 0. Does it get deleted outside of this scope? We had that issue before. But this exists for longer. What the fudge? Why is this not working? So inside a loop, I modify the data and it gets discarded. I had an issue before where I would need to construct it inside here and then pass it back on to make it exist within this loop. But that's weird. So, see this last tile? If I just don't do this, and rerun it, it should work. It should give us the first correct tile, but it still should not fill up anything else. Last tile. Here we go. Yeah, see, that works. Side IDs are all there. 0, 0, false, yeah. And here we can see indeed that this one is not the right one. This is 1 and 2, so that means south and left, which means that it's the top right corner. Okay, this is really weird. I don't understand this about this in general. I'm not entirely sure what's going wrong here. I could make like a copy of a tile and make that persist. Well, let's see. I think it's because we need to do something like this again. Ah, it's read only. I think that's the issue. So what I would need to do is do something like So tile. Because it makes a constant. That's the issue. Because the what's inside the pair is a constant. That's the freaking issue. So tile p dot. So tile dummy equals p dot second. And then I need to do a dummy instead of p dot second here. So we'll do like so we'll do like p underscore or something like that. Do like tile t underscore. Yeah. There as well, there as well. Don't care about OP because we're not writing anything into that, so I don't need to worry about that. Good, and then here we do another one just like here. T dot second, T. And here what I can do is do P. Oh god, this is gonna be doing really weird crap. P dot first, T. Let's see if this works now. I think I was going to complain about modifying the data during. Well, it works now. Well, it works now. So let's see if this works. Retry, please. Array subscript, that arrange. Should be fairly easy to fix. String, comma 8. Oh yeah. Fairly stupid that I didn't notice that. Huh, what still? Wait, which one? So buffer should be size of 8. Can you tell me the size is 8? And what is I0? 8. Of course it can't index 8. 8 is the highest number. It goes from 7, so minus 3. Yeah, that works. I know why it's erroring out, by the way. But this is great, so we can see something, alright. Let's see if this actually did the first ones happened correctly. No, see, something went wrong. Well, I think it's also because our rotation is different. What? But that should... But 1951 should be the one it starts with. What? I know why. I already know why. No, wait. No, I don't know why. Could you please count the ID, basically. So here we do so sure, just count last tile dot ID. Just to know we're actually printing the right data. I just rotated wrong. Because I already know what's kind of going wrong here. That's one step that I just ignored, which is fine. Yeah, 2311 and 3079. And then it's like gonna have some error with the sides crap, so don't worry about that. Actually, no. Current data is last tile data. Why do you... So it gets that right. So this ordering goes right, which is good. Not that we should actually be having luck there. But... No, it actually does print... No, it's 8, 8... How many characters is this? Is it 24, yeah, so it actually does that correctly, don't save. Okay, so it actually just print them all out correctly, which is good. Interesting, what's the error? Because this is not the same as what we're seeing here. Oh, is it in reverse? Holy crap, Nitro, you're an idiot. You are a fool. It's reversed. No, it's not reversed. What? But look. No, wait. No, it's correct. No, look. I thought it was reversed, but it's not. It's doing that proper. Something cut off? No. Huh. Oh yeah, of course it sticks them together. There we go. This is what we're actually looking for. I think I see the error already. We cut off one line too much on the top. So I think... Huh. Oh, fun. But where does that get cut off? Yeah, so if we check the hash hash hash, no, it's still not right. That's not it either. Is it flipped upside down? I think it is. What? How? How is it flipped upside down? Is it mirrored? Because even the first one is mirrored. Yeah, look. Dot hash, dot hash, dot dot hash. Dot hash hash. Yeah, yeah, it's exactly this line. What? So it's not like we do it in reverse order there, right? For int I equals 0, I is less than 120. Let's just do 10 here now because we know just to get that working. Let's do 120. I plus plus count picture I. Let's see. This shouldn't matter. If it does, I'm going crazy. Okay, good. It doesn't matter. That's sort of good, I guess. Does it always mirror it? Let's put a breakpoint here. Actually, no, because the thing is, even... does the data get put in proper? Yeah, what we can do is we can actually fairly easily check that by putting a breakpoint here. Just seeing what inside... So last tile should be 1951. Yeah, 1951 is last tile. And then we go to data and we just check. Yeah, so the data in here is already reversed. So when does this data get filled? So it gets read from here. So let's see, 1951. Wait, what? Dot hash hash dot dot dot. Yeah. And this line gets stripped. This line gets stripped off. So of course we just have dot hash 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 dot dot dot. Yeah. So it's actually correct. It's just it's flipped. All of it is flipped. Side ID is false, 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 false. Seems a bit wrong. Interesting. So it reads it improper. Just fine. But why does this say it's reversed? The tiles become that. So if we take a look at the connected ones, right? Oh. Wait, no, 0 is top. Ah, I see. It's not the correct one in my system. I see. Yeah, I know the issue already. It's fairly simple. It's because they rotate it for some reason. Don't know why, but sure. I just need to try the other tile ID in the corner, which is 1171, and then it should work, as I thought it would. Because in the end, it doesn't matter what the overall rotation is, because that doesn't matter, because you just rotate the entire thing anyway. So I kind of just check all 4 of them until it sort of matches up. Yeah, tile width is not, it's 3 here, and I already know why, because this is should already break on its own earlier even. But so let's see, if we rotate it, it should be 1489 211, and that's wrong, huh? How could that be, you might ask? So how does this happen, you might ask? I will tell you why. So we go here. There we go. So 1171. It's the first one we did, right? So we know the next tile is going to be this one. So we can check our next tile, 1481, and check our sides. Sorry, our side IDs. There we go. False. True. Hey, look. 3 and 3. And this is true. It's flipped. Huh. So this tells you something. It needs to be rotated. It's also in number 3, but that's not where we're looking. So what this tells us is that our right side is connected to his right side, and it's flipped. The way I can fix this is by changing the outgoing ID, which shouldn't be that one. So incoming side isn't going to be 3. It should be something else. So we need to actually change that. So what we do is here we update the last tile to be the next tile. We also need to update the incoming side. And this depends on what the value is here in 1. So that'll be fun. So if incoming, it's basically where we're coming from. Let me think. So ingoing is going to be, let's see. So let's go from the start. Incoming is 3. We come from the side. And then we do, we see here, so this is actually its left side, is 3 as well. And then we should go through the other side, which is going to be 4. Wait, do we come in from that side? I should say this correctly, right? Yeah, so it's connected on the right side, so we need to flip it. And then we need to go back to the other side, which is 3. Sorry, 2 then. IDs are confusing. So then we need to do 3. So let me think. So we know we'll always approach from the 3 side. So from where the value is 3, so it's 2. 0, 1, 2, yeah. So it'll always be the opposite side of where we entered. So what I can do is, if what's incoming? Let me see. Because last tile has its side IDs to be 1489. Yes, 1489. Which makes sense. But that's the right side there as well. So how do I realize... oh, I just need to do it before last tile, of course. That's fairly simple. So what I can do here... Because now I have last tile and next tile still. So I need to go to the next tile. I need to check what I am. Well, I can do that here as well. Yeah, what I am, and then I need to change that. So, oh no, because that data is going to be in last tile. That's why it's. I need No, because I need to check the last ID. Because that'll connect back to it. Yes, that's what I want. So what we're going to be doing is we're going to take the old ongoing ID and we're going to get the back reference. So it'll be tuple int, bool, and this will be like the back reference. And this will be my current tile. So last tile, I guess. Last tile. Let's see. So I need to find the one where the ID is the same. We don't know which one. Actually, we know that. So get one. That's the rotation, which just tells us what we need. So we know which side we came in from with that. So that'll be last tile. So yeah, that's why we need to do it here. So here we go. This will be the last tile. It'll be the index of ingoing. So it'll be dot side IDs dot ingoing. Ingoing, and then I need the second value of that. Because this won't be our back reference yet. So we do like dots. So this will be now our number. And now we need to go to next tile. Dot side IDs. And this will be the one we're looking for. Jesus Christ, that's complicated. And now we have the back reference. This will be 3 here as well. Basically, what we do is we check this 3 and we go back here. Hey, it's also my 3. So we stick the same sides together. And what we're basically going to do is if get it'll be 1 again of back reference. If this is 0, then we do ingoing equals 1. Kind of do it the same here. And then I do a bunch of here. Else. It's 1, 2, and the other one is 4. I think one of these I don't need to change. So else, ingoing. Actually, no, I should always do it changing because I know what it's going to be. Side equals 1. Anyway, so if it's 1, it means we're at the south. The next one will be at the top. if we're gonna go from the 2, which means we come from the left, 0, 1, 2, yeah. Wait, no, so it'll be 1, 2, 3, 4, yeah. 1, 2. Wait, is this gonna be? Is it all 0 indexed? Isn't it all 0 indexed? Which means I've fudged up so anyway. Yeah, incoming side, that's correct. It'll be the side from which we are approaching. So that's why it's this stupid mess. So if we were approached from our perspective, this side. This is one of those things that a human can do so easily, but it's so complicated to program in. Because a human can instantly see if he needs to flip, rotate, whatever. God, this is so much more complicated than it needs to be. Anyway, ingoing side, yes, we need to finish this bit. We'll just do bit by bit. So, we were originally approaching from the left. Human brains unexpectedly caught. It's so good at things like this. Like, making a puzzle is, like, especially at the small sizes, it's so much better than a computer. So, we approach from the left. We enter in... Sorry. From the perspective of our new tile, we came in from the left. Sorry, from our... No. Then it can be anything else. That's what I'm doing here. So, if... I basically need to get the opposite side here. 0, 1, 1 is 0, 2 is 3, and 3 is... 2 is 3, and otherwise it's 2. That's basically what it needs to be. However, there's one thing that I just remembered that I needed to think about, and that is the flipping of the relevant bits. Because if we flip one thing in the string, it flips everything else in the string. That is fairly easy to do by here, by this. If gen idea and we are not... So if it's true... yeah, or... Sorry. So if we flipped is true... So if it's true, we need to... So let's say that we just have a string of pictures, and they have a boolean that says that they're flipped with respect to their next one. So if 0 is not flipped and 1 is flipped, then I need to flip every consecutive one as well. This means that if it's flipped... So what do I do? Yeah, I do it slightly different. So here, so I do if flipped... Do that. If flipped equals, if flipped is true, false, or true. So we just swap it. If it's true, it goes to false. If it's false, it goes to true. And so, yeah. And now we should only see 3 things or an error. Stop, remove that breakpoint. Because now it should... Fuck. Still does this. Why does it still do that? Let's see, 9-7, that's correct. But what do you say then? There should be nothing there. Why do you go back? He just infinitely loops. Let's see. 0 is 1, 1 goes to 0, 2 goes to 3, and then 3 would go to 2. "17 pages only took 10 hours. Congrats. Well done. Let me think. So the issue here, so now we actually do this correctly, but then I need to know what 971 is. So what I can do is just set a conditional breakpoint. Do it like right here. Thank you. Conditional. Do like, what is it? 70-page notebook, Jesus Christ. Let's see. Condition expression is true, and this will be needs to be like next tile. Oh, next ID is yeah, let's do that. Next ID. That's an int, right? No, this. Need to do this. Conditions. What is it gonna be? 2971. Close. Oh, I know why. Interesting, it just breaks if there's a breakpoint that breaks. So it should be like, there we go. Wait, what? There we go. Alright, good. So 1171, 1489, and now we'll see what happened. So the next tile is going to be 2791. There we go. I want to go to take a look at side IDs. There we go. Because the next one should be 2, right? Incoming side is 2. And incoming side is 3. Oh, I see. Yeah, I think what I did wrong. I think I already see it. Wait, do I? Let's see. Back reference. Should be 1482 2 false. Yeah, so it's 2. Yeah, and 2 gives it to 3. That's why. But it's on R. Yeah. Do I need to take R value? Because I do need to get the one. I think I actually don't need to do this. I just need to go last tile side IDs. Because that'll just be a number. And that in this case was 3. I think I should just do that actually. The reason why it kind of does weird things before. Oh yeah, you should just be an int. I think this might work. Back reference is 3. Yeah, which means incoming side should be 2. And then this should be next tile. So now what we should do is, so we print the next tile. Actually, so that's the issue. So that's one plus thing I knew. So we print, which our crew data is from 14 whatever. Then we check the next ID, which is going to be last tile, which we haven't set yet, or about to get set, yeah. Of this, which should be 2, and hey, 2 is empty. And then we check the ID and it's 0, and we break. Only thing we need to do now is not break, we need to do something more. Because now we need to actually still print the data. Actually, no, I've got a slightly better idea. So see this data to print. So nah. That's fairly simple. But then I would say basically do no, it should still work, right? Yeah, it's actually still just work properly. Then remove the breakpoints, and it should print all 3. I think we got it. Oh god. Oh boy. So now what I do is this doesn't go from 0 into height -2. It goes from like oh god. So now we need to do it for another 4 height int height no equals 0 height equals 12 height less than 12 height no plus. Yeah, I need to know how to fix this. There we go. So basically what we need to do is change the last tile. So at the end, what we can do is we can go back to our, so basically what I do here is that, hey, no, last tile. So basically we do one more step of this, but instead we basically change something. So we do like starting number, start row 0. And this will be from start 0 to plus this. And then here we do starting plus equals height -2. Add 8 on. And then what we need to do is we need to prepare the next tile and print the data for that already. Well, we don't need to print that, we just need to prepare the data. So what we can do here is we know that this tile is the good start tile. So we just go to row starts. So we go to like last tile equals the tile we get from row start. So like next ID. So it's like this. Next ID is going to be row starts. Instead of ingoing side 3, we're going to do 2. Sorry, 1, because we go to the bottom. And I kind of do the same. I just do this again. Because what I need to check if it's rotated or not. And then I do like next ID, you do last tile equals row starts. And I kind of just do this again? Yeah, I think. kind of. So what I do is I kind of copy this all. Last tile equals next tile. Yeah. So start row we need to do all here. So this is all the other things we do otherwise. So one thing I don't do the print, the adding here. I need to do the. Do I need to do that? Because we always print the last one actually, so we don't need to. So next idea is going to be last tile dot ingoing side. Ingoing side is going to be different. It's going to be 1 here, because instead of going from 3, which is the right, we go to the bottom, which is 1. Go to get the next ID. Don't need to do, strictly speaking. If it's 0, we break. So what we actually do is just while true, kind of. And the same here, kind of while true. Because this kind of carries on until there's no more ID to find. And it basically says this breaks proper. So we break if we can't find anything next, which is good, I guess. See if this works. It might infinitely loop. So the next tile is going to be the next ID, and then we just do the data. And we basically see this might be a bit different, though. Actually, no, this should be fine. And here I need to think, though. Back references get the first data from the last tile, side IDs can going tile, going side. So that's 1 again. So it's basically, is it next? Is it just next ID? Side IDs ingoing side. Yeah, that's just side next ID. Because we don't change incoming, ingoing side. Yeah. But that should be fine because now we do a 90-degree turn basically. So instead of the 1 being there, I basically need to one that goes like to the 4. So if it's 0, it's going to be 3. If it's 1, it's going to be 2. If it's 2, it's going to be 2 is there, so it's going to be 0. Otherwise, it's going to be 1. Because if it's on that one, it's the bottom. Yes. Oh god, this might not work. Let's see if it does. Oh boy. So this in theory should give us an upside down-ish. What? Okay, so that doesn't work. So let's put a breakpoint here, see what's going on. So basically what I want to know is last tile is row start. So last tile should be... Last time, yeah, there we go. Side IDs. Well, I already... Well, that's the clear error. Should be 0. Are you still correct then? See if it works now. What's going on? What's start row? Start row is 8. Oh, yeah, I know why. I already know why, but shouldn't this work? Because start row is number 20. Huh. Yeah, no wonder it doesn't work. Shouldn't it have broken though? Let me think. So last tile is 2473, which should be 2473. It's here. Oh. Huh. Let me see. So yeah, it should have gone 2473. That's correct. Yeah, I already see why this error is out. That's fairly simple to see. But it's because... Why are there two next tiles? It makes no sense. So let's... I know what I can do. So we can fairly easily go here. And we just go the breakpoint. Take a look. Once this is done, by the way, this step... What? It already errors out before? Why? How? Start row... Start row should be 0, right? 120. What? Oh, is it because like it waits until it gets to the next line, which is gonna be this one? Yeah, there we go. There we go. Yeah, there we go. That's wrong. So how do we check what's going on here? So 2473 should have... I need to look at my last... Not my last tile, which is correct. It should be next tile. Side IDs. There we go. Because back reference is 2, which... Get in from there. I think I may have mixed this up a bit. I need to do the other ones. I think that's actually the issue. Because here we check if it's 0. So back reference is going to be, what is it, 2 here? Yeah, because this is 2. Which means we came in from its... Why do we keep referring back to the same value then? Okay, like... I need to check once more. Because the error lies in the next one. Anyway, the next one needs to be 1427, which is 1. And ingoing side is 0. That's our error. $14.27. But for some reason it stays stuck on itself. That's a weird thing. It just keeps doing it. So what I'm gonna do is I'm gonna add a breakpoint here. Should be before it even gets executed, yeah. So let's do it here. Because now it should actually count the one we're working on. 1127, 1489. And now we get to the wrong one. So here shit goes down. Continue once on again. So yeah, that's not right. So it actually gets the next tile, right? No, 1427. Wait, why isn't 2971 still there? Last tile equals next tile. Oh, is that the error? No, next tile it gets defined here. So what's going on here? Should actually do this at the end here. It's like here. I need to continue like twice or try. Did I do it wrong again? Yeah, I think I did. It's broken because for some reason a tile loops in on itself. Yeah, that's weird because it's already getting to start row 120 and shouldn't be able to. It's a bit weird. Oh, is it because it breaks instantly? I think that's why. Yeah, I think that's what's going on. So I can actually... get to this line. So it does these correctly. 1482, and it should be like here, 1489. Then it gets to 2971, which is also correct. And then it gets to 2473. And then it should go to 1427, but it doesn't. So first, let's say something like about row start should be 1171. Ah, see, that's wrong for one. So row start should be last tile. Shouldn't change anything yet, I think, because what happens is so last tile should be the one we're looking at right now. So side IDs, and ingoing side should be, is it 0? I'm not sure that's supposed to be 0. Because yeah, this what happens, it's false. Why is that going? Why is it ingoing 0? Let's see. Next ID is, yeah, see, this goes on next ID is that, and it doesn't get it doesn't get changed. I don't know how this happens though, because ingoing side should be 0. Oh, because it goes back to the, yeah, it goes back to the log, so last row. So what I'm using now should actually go to 3079 after this and then do whatever there. But it still should go on to 1427. And I think that's because the next ID doesn't get calculated properly, the ingoing side. On break now. I assume the plan now is to sleep 4 hours a day and game until you shit yourself to death. Roughly speaking, maybe. So now we're skipping until... Oh yeah, we need to actually just screw that breakpoint. We don't care. Here we go. So now we're about to do the next one. So next ID is 247, and ingoing side is 0, which it should not be. Because ingoing side should be... Let's see, next tile... side IDs. It should be 1. So let me see. So the last tile was 1171. Let's see. I think the logic in and of itself works. Sorry, it gets executed probably, just doesn't work. The numbers I filled in aren't right. So there we go. So back reference will tell us where we came in from. Back reference is 2. It's this one. So it means we came in from our left. It means we should go out our top. Which is 0, but that's not true. It should be 1. 2, 1. Wait a minute. If it's flipped, it's otherwise. Yes, I see. It's the flipped one. Here, can I go back to the previous tile? Last tile. Side IDs. It's true. There we go. That's why it's flipped. That's the issue. Here we go. So that's a fairly easy one. So, I see. So if it's flipped, it needs to be... So here we go. So flipped is... How do I check that properly? Because it only matters if they're mutually flipped. Which is actually... Oof. Huh. Yeah, so if... So if it's false, if they're not flipped, it's 3. If it's true, it needs to be the other one, so it'll be 2. Hey there, Shogun. So here it'll be 2, 0, 1. Instead of 2, it will be the other value, which is 3. It'll be 1. It'll be 0. It's going to be Nigel's whole Sunday. Maybe. I may have woken up very late. Let's see. Yeah, instead of 0 is 1. Yeah, alright. So what we're going to do is remove the breakpoint and see if it works. I think there's one more error in here. 473. No, I didn't fix it properly. You need to go back to this breakpoint and run it. Because I was looking at the wrong side. So next tile is 14. Here we go, side IDs. So now back reference is 2 and ingoing side is 0. But it should be 1. Because this is true, right? Next ID. 2473 false. Ah, I see. We don't need to look at the next ID. We need to get this one. We need to get the previous one, basically. How do I do that? Last tile. Side IDs. This value. 0. How do I... I was checking the wrong one here. I don't need to check of next ID. I need to check it of... 2473. Wait, how many one? Yeah, I am. This is tile ID 2473. Just the one I'm looking at right now. But why are you false? Because that shouldn't be possible. They should be both true. $11.71. No, it's true because it's false. 2473. Yeah. It's just the hacking minigame. No, it's because oh god. Yeah. Let me see. What was the one that I was looking at wrong? Because I don't think this was wrong before even. $11.71. So you go to 2473 because it's at your 0, which is at your top? What? Oh, is that what's wrong? Did I grab the wrong tile here? I mean, it makes sense it's at the top because that's what we did. But wait, why are you... What tile? I said 1171 to be the first. Did I misdo this? So debugged. God. So let's see. 9051, 2310, 3097. Does it break even before the breakpoint? Nice. It shouldn't in theory, but cur data, rotate cur data. What? How does it error out there? Erase subscript unarranged. Shouldn't be U2. You might need to be a 2. Because where do I error out? I0, J0. What is height? Why do you not tell me height, damn it? Do I need to go one up for that? Sure, don't worry about it. Stale. I need to rerun that. Shouldn't do that now though. It still does. I think it's maybe. I think it's on the lower end actually, not on the higher end. So let's actually do it -1 again and then rerun the code. Otherwise, it's gonna show me stale code. I'd rather not have that. try. There we go. So, well, height is 8. Sorry, 10. It's a constant. Yeah, -1 is J0. It's going to be 9, so it's going to error out on, no matter what. But why? Buffer should be height of 8. That's correct. So I is 0. So what we get is and J0. So this is going to be, yeah, 10 minus 1 is 9. It won't work because buffer has a size of 8. So if I make it 2, we rerun it again, and now it should tell me another one where it errors out. And now it happens here with J is 0, I is 0. Oh, is buffer just nothing? Size of 8. No, that works. So is it I? I is 0. Wait, what's array subscript out of range? Because position 8, that's fine. Because position... Oh, you need to be -2. And you need to be with -2 as well. Oh, that would explain that one. How did that not error out before? What? How are you still erroring out? Position is 8. Size type pause 8. Size -1. Oh, it's -2, but it's -3 because we're doing a for loop here. Yeah. No, there should be minus. So we're getting to 8 now. Yeah, that's why, because it can't be ever be 8. It needs to go to 7 max. How is it still erroring out? You'll still give me 8. Oh, Jesus, it's all it do the same thing everywhere that I did wrong. Good grief. So now I should actually get to the... Hey, that's a string subscript out of range. Nice. Because you should also be -1. No, because how? You should be your offset 1. It's annoying. I is 1. S plus equals buffer height. Buffer height, so J is 0, which means this will be 7. Wait. What's going on here? Let me think. Yeah, so that's true. I is 1, so now we're going into the second row of characters. Sorry, second column. Huh. So let me think here. Oh wait, 7 is empty. Why is 7 empty? That's not right. So what tile are we on? I've been spending almost 4 hours on this, good grief. I'm pretty sure that others have already completed it. Me, Aftish, and Hamster have all done part 1, but not part 2 yet. That's pretty great. Still, what's going on here? So it works for the other ones, but for some reason not for the others. So let me just first rerun so I can actually look at my nice code. Here we go. So it's 3079. Give me a retry. Tell me the line. Exactly the line. Which is called from here. Rotate cure data 1. Oh, I think I know why. What is it? Extra rotation. So yeah, see, it already gets called once and extra rotation -1. I think it like makes it smaller or something. Yeah, I think that's what's going on. So you should not be -2. And just you should be -3, right? Oh, there we go. Now we actually get there. So let's see. 3079. You are the ID. IDs were relevant. Just the last tile we checked. So the last tile was 1951. Good. 1951. So next tile should be 2729. 2729, good. And the ingoing side 2. So let me see, next tile side is 2, which is nothing. So let's see, 1951 came from 1, which is the bottom. So we flip it around, which means the next one should be what was on the original. So that should be 2. That is 2. What? So we have 1951 and 27. Yeah. And then we should take 1472 and 3. Did I mess this up? So did I mix these up? So let's see. Back reference is 1. And this is false, so it should be 2. That's what it says. Did I just flip these around? Let's see. Ooh. So you should always, from 0 goes to 2 or 3, or 1 goes to 3 to 2. That always makes sense. I think I just flip them around, because it says 2, but it should be 3. Get logic. I need to make sure this meshes in my head. Background is 1. So this thing is like in it upside down. That's how it is. So I know 1 means that it should be. So I know we get from like the bottom. And then my instinct says, okay, I need to go to. It feels like this 3 should be a 2 that's flipped around the wrong way. 2971 should not be on top then. But maybe it's because it's like rotated? Yeah, because it's rotated, right? So next ID, so it goes to the last tile, side IDs, it's all false. That should be right. Because it means that you're 1564. Wait. Sides. That's not right. Side should be 564. They don't see that data anywhere. What? First I can remove reversed. Huh, so this is a bit weird. So it seems to have flipped this around because this indicates this is the one that's on top and this is the one that's on the bottom. But as you can see, 1951 is on top and this one's at the bottom. And then this one should be to the right. So that's number 3. But it's not. Because it's these are reversed, so this should be 2. And that's my confusion. So so I checked that stuff here. Good grief. Huh. So that's where an error lies as well. And I could bake it in and see if I can fix it. Because what it's going to do now is going to quit. It's going to try ingoing side 2, which is 0 of the next tile. And it's just going to stop. So I can just try reversing this if it's a standard issue in my algorithm. And then 2... So 0 is this, 2 should be 1, 0, yeah. And then we should be done. No, see, it keeps repeating. It just keeps repeating forever. So two, 4, there, that goes right, then 2792, 472, 2473, and then it goes back to 2792. House last tile 1951. What's row starts? Well, that seems not correct. What? Let me see. Last tile equals row starts. And then row start equals last tile. So that just says row start is the same. Yeah, no wonder. You fool. So next idea is 2971. No, it's 2729. Yeah, this should have. So you should be the row start after this, right? And what is next tile? There we go. That's the issue. 1, 2. Oh my. Oh my, we're somewhere. We are somewhere, kids. However, I'm pretty sure it's now rotated incorrectly. So one thing I can do is just get rid of the count of the tile ID. We don't care. Actually, no, that's probably decent RT. I want to rotate this. However, we can already check if it's correct by just comparing it manually. This will be arbitrary. This should be the same, but the individual tiles might be rotated. Oh boy. Because I think there was some error with the rotation and the mirroring. But how do I figure that out? So one thing we can do is we can actually do... So here we do plus a space. And at the end we do an end line. Oh, yeah, I know why. If I modulus 8 equals 0. There we go. There we go. Because I think they're individually rotated or something. It's a bit of a weird thing. Wait, what? Oh, yeah. Let's rerun that. Oh, there we go. There we go. So let's see. So here we can now individually compare this even. Oh, I think I see the errors issue already. It's the same thing we had before, weirdly enough. So see, dash dot dot. So I want to know if they're all. See, this is the error. They're not all rotated correctly because I assume the first one is rotated already in a proper way, which it's not. I think it's because I need to start flip that true then. Or not? What? False. Oh yeah, because it needs to get rotated beforehand, even. That's the issue. Yeah, that was the error. So it's like it's not the logical starting point, that's why. What is incoming size 3? Yeah, that's correct. So, yeah. I need to flip this before already. Can do that here in theory, actually. If... So... where do we even define cur data? Oh, yeah, here. I don't think this is actually an issue with the original data sets. But it's a bit difficult to check that, unfortunately. So how do I even check this? God. So now the first row is not correct. So this one is, but this one is then flipped the wrong way around. This This is such a mess. Oh my god. So this one needs to be flipped. But the thing is that this means that this one is like the true. So this one is true, which means it flipped. Oh, well that's not right. That might explain that a little bit. It does seem better. Hey, that's better. So now we get hash dot hash yada 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 yada. That's all correct. But then the next row is wrong because it needs to be mirrored about this axis, so like this axis, which is a bit weird. And you need to be then flipped about this axis again. And this is... what? This one's just wrong. There should be a full stop in there. Why? What? Two three one one three seven two 242 2473. Yeah, that's all right. But the interesting thing is I can do the traversal right with like the individual rotations there. I just don't get the the other rotations right, which is a bit strange. Yeah, where does that come from? It seems like the data for that is not being parsed properly. So let me see. That should be 2473, right? 2473 doesn't have it. Wait, yeah. Hey, you're that one. Because the one before, 1472. Oh, okay. Is my offset wrong somewhere? No, sorry, first and bottom line don't get used at all. So we need to look at like this. Which is you. Yeah, perfect. That's fine. So 2971. I think that data doesn't get transferred properly or something. We can fairly easily check this by just putting a breakpoint here. Anyway, I think I'm actually going to stop soon and go do some groceries and other stuff. So I can go to tiles. I can go to what was it again? I want to look at memory at the end. Oh. Just give me a breakpoint there. Never gets reached. Nice. Let's put it here. Fine. Do it like that. We need to get an answer there anyway later. There we go. So it's you, which is 2473. 473. Which is oh no, look, there it is. It's a giant block of hashes. So this seems to work just fine, just flipped. Yeah, that works perfectly alright. 2473. Huh. Did I copy this properly? 2473. Yeah, a giant block of hashes. Oh, I know. Look, here it is. I'm being stupid. Which means that also rotation is incorrect, which is good to know, I guess. Yeah. So for this, our rotation is correct, actually. Huh. It's actually perfectly alright. That's perfectly fine. Yeah, so the first row is fine. And then it seems to correct itself at some point. No, because you need to be... Ah, no, look, you're... Still not correct? There's two axes. Yeah, so it's rotated incorrectly. Because look, this block of hashes is here. So this needs to be rotated some amount. I think I get the rotation amount wrong somewhere as well. But the good thing is that it's all in the data now. So it's all in here. In here-ish. So with this rotate stuff, that's wrong. God, let's think about this. No, actually, I think I might just call it here, because this will be a lot of debugging, looking, and stuff, and I really should actually do something today. Anyway, that was pretty fun, though. I like this kind of problems. It's a lot of... Okay, actually, I don't like this part, but I like the visualization, because after this, kids, we're gonna reject this. We're gonna fucking reject it. We're gonna manually count, but we're gonna find what... We're gonna play find... We're gonna play Where's Waldo, fucking rejects and by hand. It's gonna be great, kids. Anyway, cheers for watching. I might be back tonight. We'll see. No guarantees. So I'll see you then. Cheers.